Okay, in the past we've looked at things like synthetic division to find factors. We have used different means to find how a graph starts and ends, depending which quadrants. Today we're going to look at the middle behavior, how it crosses the x-axis or how it doesn't cross the x-axis. All that depends on what we have for factors. So let's start with lines, and a very simple one, x plus, say, 3. X plus 3 has an x-intercept at -3, so it crosses right here. And again, what's key is that it's a simple cross. It goes across the x-axis and keeps going. Let's try another one. Change this, say, to -2 over 3 x plus, no, let's say 2. Again, the negative is not going to affect how it crosses the middle. It still has an x-intercept, in this case a +3, and notice the line just goes right across. Let's try another one. (3x minus 1). Again, we can expect that this is going to go right across the x-axis and go straight through, not stopping, nothing. There it goes right across at +1/3, sorry. Okay, so here's the next question. What if we were to have two factors, but both of them are different? So in other words, this is a factor with a power of 1, x minus 2, and this is a factor with a power of 1, say x plus 3. We're going to have an x-intercept at 2 and an x-intercept at -3. What's going to happen? How are they going to cross the x-axis? Well, here we go. -3 just goes right through. +2 just goes right through. No change, no surprises. So with that in mind, if the power is 1, it should just go across, straight through, right across. Does not look for any fancy, dancy stuff. Let's do a few more very quickly here. What if this were -2x plus 5? Let's just say that. The minus sign will not affect it because it's not changing the power. It should still just cross. As you can see, here's one x-intercept, it goes right across. There's a second, goes right across. So if it's a single power, it'll go across the x-axis and not stop or do anything fancy. What would happen if we had 3 of them? Let's add another one in here. X plus, say, 4. So an x-intercept at -4. Is that going to change things? Again, notice none of these factors, not a single factor here, here, or here, has a power of 2. They're all powers of 1, so every one of them should just cross. At -4, just crosses. At +2, just crosses. At 2.5, just crosses. So if the power is 1, it's just going across. Okay, let's do a change-up now. What if we were to make this different and say, instead of having a power of 1, I put on a power of 2. X minus 1 to the power of 2. It's going to have an x-intercept at 1, but what's that power of 2 going to do for us? In the middle of the graph, at 1, we get a bounce. Because the square changes the values from becoming negative as you go across to positive, it bounces it back in the same direction. So let's have another look. Change that, say, to +3. Bounces back. A square, the squared power, bounces back. And if I were to change that to negative, say negative x plus 2 squared, nothing more should change. We still should get a bounce. And we do. So if it's a single power, it crosses right across the x-axis. If it's a square, it bounces. That leaves one last possible thing to look at. But actually, before I do that, let's look at taking this one step further. And if I put, say, an x minus, let's say, x plus 3 on here, we have one that's squared and one that's cubed. Or, sorry, one that's single. So, one of these x-intercepts will bounce. That's right there. But the -3 intercept still goes right through. If we look back at that, it's a single power. Okay. One last example. This is all that's left. For this course anyway. There are more other things. What if I had a power of 3? X minus 2. Oops, I missed my front bracket. X minus 2 cubed. If it's single, it passes right through. If it's squared, it bounces back. If it's a cube, 3 of the same number, what happens? We get it being tangent to and crossing. It hangs around the x-axis. The technical term is tangent to and cross, but for me, hangs around and cross, however you want to say it, is your choice. 3 basic behaviors of how it can happen in the middle. If it's a single power, goes right through. Double power, square, bounces back. Triple, cube, crosses through, but it hangs around. Tangent to and crosses. Those are the 3 possibilities. For our course, that's all there is. 3 possible middle behaviors, no others. So that's it for this lesson.